We're going to cover the rest of 2.4 today, so this is 2.4 part 2. We're going to write equations using 2 points. Actually, we're going to write equations using point-slope form into slope-intercept form. And we're going to determine if lines are perpendicular or parallel using the equations, as well as writing equations for lines that are perpendicular or parallel. So point-slope form, we had it last year in geometry. The equation of a line with a slope of m and a point x1, y1, it's going to be the variable y minus y1, which is the y coordinate. So this is going to be a number, this is a variable, is equal to the slope times the quantity x, which is a variable, minus x1, which is a coordinate. Because of the slope of the line is constant, it's possible to use any point on the line and the slope to write an equation in point-slope form. Okay, so let's look at an example. Okay, write the equation of the line in slope-intercept form with slope minus 5 through 1, 3. So we're going to start by putting it into point-slope form. So this is kind of an alternative to what we did last time. So if we plug in our x1, y1 into the appropriate places and our slope, you get this, and now we can simplify it to be into slope-intercept form. So we're going to distribute our negative 5 I guess we're starting down here. So this is a simplified point-slope form. Distribute our negative 5. So negative 5 minus 1 is a plus 5. And now all we have to do is add our 3. And we're in point-slope form. So this is an easy way to rewrite into slope-intercept form with a slope and a point, as opposed to having to plug things in yourself. So the final slope-intercept form is y equals negative 5 plus 8. Okay, so write the equation. You write the equation of the line in slope-intercept form, and you can use any method that you would like. To do that, you can put it into point-slope form first, or you could use the method we learned last time. Okay. So let's look at parallel lines again. This is something we had last year. For two lines, if both slopes are defined, then the slopes of parallel lines are equal. So if we have equal slopes, the lines are going to be parallel. Here's an example. y1, this is actually equation 1 is 2x plus 1. Equation 2 is 2x minus 3. These lines are parallel. The slopes of parallel vertical lines are undefined. So, which makes sense because you don't have a slope, or it's an undefined slope for vertical lines. Horizontal lines will both have slopes of 0. Perpendicular lines, for two lines, if both slopes are defined, then the slopes of their perpendicular lines are opposite reciprocals. Their product is equal to negative 1. So if you forget what opposite reciprocals are, you can maybe remember this. Vertical and horizontal lines are always perpendicular. So again, we're going to have a slope here of undefined and a slope here of 0. So this rule doesn't necessarily apply, but hopefully you know if a line is vertical and another is horizontal, they're going to be perpendicular. So here's the first equation, 2x plus 3. Second equation, negative 1/2, and my lines seem to disappear, negative 1/2 x plus 1. So negative 1/2 is the opposite reciprocal of a positive 2, which if we wrote it as a fraction would be 2 over 1. All right, so that's how we can tell if lines are parallel or perpendicular. Now we're going to actually write equations for parallel and perpendicular lines. Write the equation in slope-intercept form of a line that's parallel to y equals 1.8x plus 3 and goes through the point 5, 2. So we know right away that what the slope is going to be. So we have a slope and a point, and we could use any of our methods to write the equation in slope-intercept form. So they've chosen to start with point-slope form. So here's our x1, y1. We plug them into the right places, our m and our x1, y1. Now we're going to distribute and add 2. And that gives us y equals 1.8x minus 7. So that is the line that's parallel to the given line and goes to the point 5, comma 2. Likewise, if we want to write an equation for a slope that's perpendicular to the line y equals negative 3 halves x minus 1 and goes through this point, well, again, we know what the slope is. It's going to be the opposite reciprocal of negative 3 halves, which is going to be a positive 2/3. So if this is our x1, y1, we can plug it into point slope form. Remember, we're going to have y minus y1, which is a negative 2, equals our slope, x minus, y minus y1 is equal to slope times x minus x1. So this subtraction of a negative makes this a positive 2. And now we distribute, simplify by subtracting 2. And here is our equation of the perpendicular line. So the point slope form can be very useful to getting things into slope intercept form, given a slope and a point. But again, we have multiple methods and ways of doing that. That wraps up this lesson. So here's your homework. Bring any questions to class.